This is oxidation reduction reactions. By the end of the presentation, you should be able to assign each element an oxidation number in ammonia, carbon dioxide, and calcium phosphate. Identify the oxidizing agent and reducing agent in the following reaction. Alright, so oxidation is loss of electrons. So this element or compound loses electrons, and when you do that, you become positive. And the other element's going to gain electrons, and we call that reduction. We're going to gain electrons, we call it reduction. And it becomes negative, okay? So it gets a little confusing when you think of gaining electrons as being reduced. Alright, so here's some anagrams, acronyms to remember. Oil rig, oxidation is loss, reduction is gain. Or Leo goes grr, loss of electrons is oxidation, gain of electrons is reduction. Alright, rules for assigning oxidation numbers. Y'all need to write these down. Elements found in their elemental state always have an oxidation number of 0. Individual cations and anions always have an oxidation number equal to their charge. So remember when you look on the periodic table and you've got the +1, +2, and then over here +3, plus or minus 4, that's what it's talking about. Alkali metals found in compounds always have an oxidation number of +1. Alkaline earth metals found in compounds always have an oxidation of +2. Hydrogen has an oxidation number of -1 when bonded to a metal, and +1 when bonded to a non-metal. Oxygen in any compound will always have an oxidation number of -2. For neutral compounds, ionic or covalent, the sum of the oxidation numbers will always equal 0. And for polyatomic ions, the sum of the oxidation numbers will equal to the charge of the ion. Alright, so let's balance these redox reactions. First, you're going to assign the oxidation number. So silver plus has a +1 charge. It has a charge here. It tells you exactly what it is. Aluminum is in its elemental state, so it's 0. Silver is in its elemental state, so 0. And aluminum now has a +3 charge, so it's +3. So then we need to identify the reduction half reaction and the oxidation half reaction. So let's look what happened to silver. It went from being a +1 to 0. That means it gained an electron. So if you remember oil rig, reduction is gain. So this was reduced. So this is our RHR. And then aluminum went from 0 to +3. That means it lost 3 electrons. So it was oxidized. So this is our OHR. Alright, now we need to write the half reaction. So the first reaction was silver going from plus to 0. Now, since this is a 0 over here, what we need to do is we need to balance this reaction. So if I add 1 electron over here, that balances it. And then we have aluminum. So aluminum goes from 0 to a +3. So to balance these electrons, I need to add 3 electrons over here. That way a +3 plus a -3 will equal 0. Same thing up here, a +1 plus a -1 will equal 0. Then we need to, okay, so we balanced them. Then we need to actually balance the overall equation. So I've got 1 electron here, 3 electrons here. So I need to multiply this whole equation by 3. So I'm going to rewrite that down here. So then I've got 3 electrons plus 3 Ag plus gives me 3 Ag. And our aluminum stayed the same. Okay? So then now we just need to write the complete redox reaction. So we have, and that I'm going to combine these two. So I'm going to combine my 2 equations. Plus 3 Ag plus my aluminum, because that's on the product side, the reactant side. And then 3 Ag, stop it, my cat's chewing, go on, plus aluminum plus 3 electrons. Okay, I see I have 3 electrons on this side, 3 electrons on this side, they cancel out. And if they don't cancel out, you've done something wrong. And then we'll just write our equation. It's all balanced. So basically, this is how you balance a redox reaction. Al plus 3. There we go. Alright, so let's try this one. First, we need to identify what's being oxidized, what's being reduced. So zinc is a 0, hydrogen plus 1, zinc 2 plus, and hydrogen, it's in its elemental state, right, because it's diatomic, so it's 0. So zinc went from 0 to plus 2. That means it lost, so it was oxidized. Hydrogen went from plus 1 to 0. That means it gained, so it was reduced. And I'm going to write my half reactions. So zinc goes to zinc 2 plus, and hydrogen plus goes to H2. Okay. So my zincs are balanced. I just need to balance my electrons, 2e. Here, I've got 2 hydrogens, so I really need 2 hydrogens over here. And then I'm going to look at my charges. So I have 2 plus charge over here. I have a 0 over here. So I need to add 2 electrons over here. Then I'm going to rewrite my equation. Oh, whoa. Weird. Oops, nope. Okay. Plus zinc yields zinc 2 plus 2e plus H. Okay, so my 2 electrons on each side are going to cancel out, and then I'm just going to rewrite my equation. And it's perfectly balanced. Alright, if you can't answer the questions at the beginning of the video, then watch it again.